Welcome to qnawire.
In this problem, we need to solve for the angular velocity of the bowling ball and the velocity of its mass center after it has resumed rolling. So I have here a sketch of the problem. So the ball with a mass m and radius r, initially at position 1, moves down the ramp without sliding. The ball then lands the lane, so it's position 2, and after slipping for a short distance, it starts rolling again, as you can see in position 3. So the moment of inertia is given, so it's I equals c mr squared, where c is a constant. So we can solve this by applying the work energy theorem first. So from the work energy theorem, we'll have the work energy theorem is the equation for this is K. So K1 plus that's the kinetic energy, initial kinetic energy, and then the initial gravitational potential energy, so UG1, then the initial plus the initial elastic potential energy, so UL1, then plus the work done by non-conservative forces, so is equal to the final kinetic energy plus the final gravitational potential energy plus the final elastic potential energy. So based on the problem, so we don't have the initial kinetic energy and we don't have elastic energy involved here. So there's no work done by non-conservative forces also. And then for the after, or the final state, so we don't, our potential energy, gravitational potential energy is 0. Hence, we're left with the initial gravitational potential energy equals the final kinetic energy. So, substituting the equation for potential energy and kinetic energy, so we'll have, so mgh equals, so 1/2 mv sub 2, then plus 1/2 the moment of inertia, then angular velocity squared. As we know, the linear velocity can be expressed in terms of r and omega. So we'll have here, so v2 equals r omega sub 2, and from there we can get the equation for omega. So omega equals v2 over r. So we can substitute this in our work energy equation as well as the given equation for the moment of inertia I. So our equation will become, so mgh equals 1/2 mv2 squared plus 1/2 cmr squared times the equation for omega, which is v2 over r, then square the entire thing. So we could cancel out the masses on both sides. Okay, and then the radius here, radius squared. So we'll be left with GH equals, so 1/2, factoring out 1/2 V sub 2 squared, then times 1 plus C. So solving for V sub 2, so V sub 2 squared be equal to 2GH over 1 plus C. And finally, so get the square root of both sides. So we'll have V2 equals the square root of 2gh over 1 plus c. Now, we will apply the concept of impulse and momentum. So, here's a diagram to help visualize the scenario. So, this diagram shows what happened between time 2 and 3. So, the ball slipped for a short distance, then starts rolling again, so as stated in the problem. Hence, our equation will be, so I omega sub 2 plus m v sub 2 times r times cosine theta equals 1 I omega sub 3 plus m v sub 3 times r. So, substituting the equation for I, for the moment of inertia, for v sub 2, and expressing v sub 3 in terms of r and omega, so this equation becomes, so c m r squared, then v sub 2 over r, so this is the equation for omega sub 2, then plus m v sub 2 r cosine theta equals, so c m r squared omega sub 3 plus m r omega sub 3, so this is the equation for v sub 3 times r. So, simplifying, so this would become, so cmr v sub 2 plus m v sub 2 r cosine theta equals cmr squared omega sub 3 plus mr squared omega sub 3. So we can factor out mr for both sides, and this will be cancelled out. So our equation would be reduced to, so v sub 2 c plus cosine theta equals r omega sub 3 c plus 1. So substituting the equation for v sub 2 and solving for omega sub 3, so we'll have, so omega sub 3 from the previous equation, as you can see, is equal to c plus cosine theta all over r times c plus 1 times v sub 2. So, substituting the equation for v sub 2, so this will become c plus cosine theta over r times c plus 1 times the square root of 2gh over 1 plus c. So, further simplifying the equation, so this will be equal to, so c plus cosine theta all over r c plus 1 raised to 3 halves times the square root of 2gh. So this is our v sub 2 and then for v sub 3, solving for so this is our omega sub 3. So this is the expression for our omega sub 3. And now, solving for v sub 3, so v sub 3 is equal to, so r omega sub 3, then substituting the equation for omega sub 3, so that would be r, then multiplied by c plus cosine theta over r times c plus 1 raised to 3 halves square root of 2gh. So our r will just be cancelled. So, V sub 3 is equal to C plus cosine theta over C plus 1 raised to 3 halves multiplied by 2GH.